hello, welcome to Learnwizz. It's me, Linus. Hope you have watched the last video of electrochemical cells. In this video, we'll be discussing about electrolytic cells. Okay, so electrochemical cell, in electrochemical cells, the energy conversion was chemical energy is converted to electrical energy. Okay, but in this electrolytic cells, here, electrical energy will be converted to electrical energy is converting to chemical energy. So that is the energy. First difference between electrochemical cells and electrolytic cells. Okay. So here electrical energy will be converting to chemical energy. So basically, in the case of galvanic cell, we discussed in the last video, there were two half cells, okay, and two electrodes and two electrolytic solutions over there. But in this case of electrolytic cells, the reaction takes place in a single electrolytic solution. Okay, that is the main difference. So in this session, we'll be discussing about electrolysis of sodium chloride, that is molten sodium chloride, and aqueous solution of sodium chloride. Okay, first of all, let us discuss about electrolysis of molten sodium chloride. So what is mean by molten? Molten sodium chloride. What is that molten means? It is in the melted form. Okay, sodium chloride. And we know that sodium chloride is an ionic compound. It cannot conduct electricity in its what state? Solid state, because ions are not free to move, right? So we have to take either in the form of molten, melted form, or in the aqueous form, right? So in this case, first of all, we are going to discuss the electrolysis of molten sodium chloride. Okay, so we have taken an beaker and we have taken the which solution? Molten. We have taken here molten sodium chloride. Okay, molten NaCl. Okay, and we have to dip two electrodes. Okay, anode and cathode is in same beaker. Okay, two electrodes we have to take. Okay. And what is next? We have to connect this anode and cathode through battery. Okay, battery. Okay, so we are doing electricity. We have to pass electricity. Then only the reaction will take place. Okay, now molten sodium chloride means what are the different ions present in molten sodium chloride? Yes, Na plus ions will be present. Also, Cl minus ions will be present. Okay, and while studying the electrolytic cell reaction, you had to study a word that is in the galvanic cell. When we were studying galvanic cell, we discussed a word lone, right? LOAN. We discussed a word lone, left is oxidation, anode and negative galvanic cell. So you have remember, right? In this case, we have to remember another word that is LOAP, lope. Okay, and same in the left. And this is oxidation, O for oxidation always, and A for anode. And what is the difference between galvanic cell and electrolytic cell is that anode is positive charge in this case. Anode is positive. So just study this word lope. Okay, and we know that oxidation means what? It is loss of electrons. Loss of electrons or oxidation. Okay, and I will give you one code to study this oxidation, and oxidation is loss of electrons. You will have heard about the word oil rig, right? Oil rig. Just keep in your mind this word oil rig. What is oil rig? Oil rig. So expand it like this. Oxidation is loss of electrons. Okay. And rig means reduction is gain of electron. Just opposite. Okay. Just study one word oil rig. So you will be getting the complete definition of oxidation and reduction. Oxidation is loss of electrons and reduction is gain of electrons. Okay. Now what you have to do is you have to do electrolysis of molten sodium chloride, right? So we have taken the beaker here. We have dipped anode and cathode. Okay, we have dipped anode and cathode, and we have taken the sodium molten sodium chloride here. So it is already melted and it has become ions, right? So what are the different ions present? Sodium ions are there, chloride ions are there, lot of sodium ions and chloride ions, right? Yes. And I told you that left side we are taking anode. This is anode. And what is the charge of anode? We have already said that in the case of electrolytic cell, it is positive charge. So this is a positive electrode, okay, anode. And automatically this is cathode. And what is the charge of this cathode? Yes, this is a negative electrode. Okay. Then we have to connect this to what? Connect this to a voltmeter. Okay. Sorry, battery. We have to connect this to the battery. In the last case, galvanic cell, we connected it to the voltmeter. Okay, external source is not needed. But here, external source, electricity, we have to pass, right? Okay, then what will happen? So, just think that we know that anode is positive, right? Anode is positive. And there are so many sodium ions and chloride ions are present in this solution, in this molten sodium chloride. And who will go to this positive electrode? Just opposite charge will attract, right? So you guys now have to understand that who is that, who is coming here, who is coming here. Chloride ions will be coming, right? So chloride ions will be coming to this positive electrode. Cl minus ions will be coming to this positive electrode. Okay, so at anode, who reached? Cl minus reached, right? Cl minus has reached this anode. So what will happen at anode? Of course, anode always takes place oxidation. So oxidation is going to take place at anode. Okay, what is oxidation? Of course, we studied oxidation is loss of electrons. So chlorine is coming, Cl minus is coming, right? It is already having one electron, right? So it has to donate that electron, right? So what you have to do? Cl minus gives losing, right? Cl minus will become Cl by donating its one electron. So just understand that anode is positive. So automatically the negative ions from the molten sodium chloride, that is chloride ion, will be coming to anode. And when it reaches the anode, oxidation reaction takes place. And what is oxidation reaction? It is loss of electrons. So Cl minus, which is already having one extra electron, will donate that electron and will become Cl. Okay, clear? Okay. Then, and we know one more thing, we know that chlorine always, it is a diatomic molecule, right? So chlorine has to exist as Cl2, right? So to make this Cl2, what you have to do? To make this Cl2, what you have to do is, yes, Cl minus loses Cl plus one electron. And to make it Cl2, you have to take two chloride ions. Lot of chloride ions are there, right? So you have to take two chloride ions, okay? So it will become what? Cl2. And one chloride ion is donating one electron. So there is two chloride ions. So it has to donate how many electrons? Two electrons. This purpose, this is only for balancing, okay? Only for making the appropriate to make it chlorine a diatomic. That is only thing, right? So this is the correct equation. This is correct. But to make it clear, to make it a diatomic molecule, we know that chlorine is diatomic, so that we balanced it. That is only we have done in the second step. So from this we have understand that at anode, who came? Chlorine came, right? Cl came, and which gas is liberating? Cl2 gas is liberating at anode. So after the reaction, you will observe so many bubbles, chlorine gas, right? So many bubbles near this anode of this cell. Okay. Now let us go see the what is happening at cathode, right? So at cathode is negative charge, right? So cathode is negative, and who will be coming to cathode? automatically Na plus will be coming. Okay, Na plus reached here. Na plus reached the cathode, and cathode. What reaction is taking place at cathode? Anode is oxidation, so cathode is reduction. Reduction will be taking place at cathode. And what is reduction? Yes, reduction is gain of electrons, right? Gain of electrons. So this is sodium plus, right? Sodium plus is already loses one electron. It will gain that one electron and become sodium. Okay, so how the reaction at cathode is, what will happen at cathode? Sodium Na plus will gain that one electron and become sodium. Okay, now we have to do balancing here, because here anode 2 electrons are donated by this chlorine, right? So sodium is taking here 1 electron. To make it 2 electron, just balance. You have to take 2 sodium ions. So that 2 electrons are gained and you will get 2 sodium atoms. Okay. Lot of reactions will be taking place. Okay. So now tell me what is produced at cathode. Yes, at cathode, sodium metal is produced. Sodium metal is produced at cathode. Okay, so this is the reaction that is taking place by the electrolysis of sodium chloride. Very simple, right? When you understand the concept, it is very simple. First of all, you just understand that electrolytic cells are cells that is used to convert what electrical energy to chemical energy. Okay, so when you pass electricity through the molten sodium chloride, there will be only two ions in the molten sodium chloride, sodium ions and chloride ions. And you have to study this word loop. Okay, that is left side oxidation, anode and positive. Okay, so while studying this word, you will understand that in the left side we are taking anode. Anode is always positive in the case of electrolytic cells, and at anode oxidation is taking place, and oxidation is loss of electrons. And we know anode is positive here, so automatically the negative ions will be coming and attaching the anode, right? So who is negative? Cl minus is the negative one, right? So it will come and attach this anode. Okay, and at anode it is loss of electrons, right? The process taking place. So Cl minus will lose its one electron and will become what? Cl. So to make it balance, you have to take 2 chloride ions. Moving to the cathode. Cathode is negative charge, so automatically sodium ions, sodium plus ions, which are positive, will come to the cathode. When it reaches the cathode, it will undergo reduction reaction, and reduction is gaining of electrons. Sodium plus will gain its one electrons and it will become Na, sodium metal. So basically, after the electrolysis of molten sodium chloride, chlorine gas bubbles will be produced at the cathode. After the electrolysis of molten sodium chloride, sodium ions will be after the electrolysis of molten sodium chloride, chlorine gas, that is chlorine bubbles, will be produced at the anode and sodium metal will be deposited at the cathode. Okay, yes. Now we have to move through the electrolysis of what? Electrolysis of aqueous solution of sodium chloride. Aqueous solution of the same sodium chloride. So, in the molten state, there were only 2 ions, sodium ions and chloride ions. But here, we are taking sodium chloride in water. Aqueous means in water, right? So, water ions will be also present. So, we have to consider that also. Okay. So, that is the thing you have to be careful in this case. Okay. Then what is happening? Let us see. So here we have taken similar case. Okay. So similarly, we have to take a beaker. We have to take what? Aqueous solution of what? Sodium chloride. Okay. And again, we have 2 electrodes anode. Anode is positive and this is right side cathode. Cathode is negative. Okay, and we have connected this through the battery. Okay, battery. And here we have taken aqueous solution. So which are the two different types of ions present in aqueous solution? Sodium, automatically Na plus ions will be there, right? Cl minus ions will be there, right? Na plus ions will be there. Cl minus ions will be there. Then what ions? Water contains which are ions? H plus ions and OH minus ions, right? And we know that H plus ions are really unstable. So it will combine with the one molecule of water and form H3O plus ions. Okay. So in the solution, which all particles will be present? Sodium ions will be present, chloride ions will be present, and H3O plus ions will be present, and OH minus ions will be present. Okay. Clear? Okay. Yes, so here we have taken NaCl plus water. So the different ions present in this case is Na plus, Cl minus, and H3O plus and OH minus. Also water will be present because pure water is a bad conductor of electricity. We know that, right? Why? Because it does not dissociate completely into its ions, right? That is why. Okay, so water content will be there. That is why I have written H2O. Okay, so now let us see which ions will be going to which all electrodes and what are the reaction taking place. Okay, let us see here. And we know anode is positive. Okay, this is negative. Now see who will be coming here. Na plus ions are there, Cl minus are there, OH minus are there, then again water is here. So many ions will be there. Okay, I am just writing each ion one time. Okay, then OH minus I have written, then H3O plus. Okay, now this is positive electrode, which is anode. So negative ions, right? Cl minus and OH minus will go to that anode. Okay, who will go to anode? Yes, Cl minus ions and OH minus ions will be going to the anode. Okay, automatically there will be some competition, right? Because both two ions are there, right? OH minus and Cl minus. And there will be competition between these two ions. And yes, our chlorine is going to win the race. Okay, so here also, same like molten sodium chloride, chlorine will, both ions will reach, and this chlorine will first undergo which reaction? Oxidation. Okay, so like that, Cl minus will lose its one electron and become Cl. Again, we have to balance this to make it Cl2. We have to take 2 Cl minus and it will become Cl2 plus 2 electrons. Okay, same reaction. So you can see after the reaction, same chlorine bubbles will be coming here. Okay, same chlorine minus will be coming. Chlorine gas bubbles will be coming at the anode. Okay, similar to molten sodium chloride. So cathode at anode there is no change. Okay, always chlorine gas is produced, both cases. But here going to be a twist in cathode. What is the twist? Who is coming? In the last case, molten sodium chloride, sodium ions came. There were only sodium chloride ions, right? So it has to come here. But here you can see Na plus ions are there. And what is the other positive ion present? H3O positive ions are also there. But here there is another twist. I told you that there is some twist here. What is the twist is that here you can see there will be competition between sodium ions and H3O plus ions. But the real one who is going to attack the cathode is not Na plus and H3O plus ions. It is our water. Okay, so here water is going to attack before Na plus and H3O plus ions. So what will happen? Water will reach here first and it will take 2 electrons. That is, it will gain 2 electrons and release hydrogen gas. Okay, this is the reaction taking place at cathode. So it is little bit different here. So you have to note down this. Okay, reaction taking place at cathode when we are doing electrolysis of aqueous solution of sodium chloride. Okay, so just keep in your mind that instead of the positive ions, H2O will go and attack the cathode. Okay, so that which gas will be released? Hydrogen gas will be released. You can also see bubbles in the cathode after doing electrolysis of aqueous solution of sodium chloride. Okay, here not Na, not H3O plus is reactive. Who is coming? Water is attacking here. That is very important point you have to note. Okay, so at last, how will you conclude is that we have to conclude like this: molten NaCl, okay, and aqueous NaCl, anode and cathode. What is happening? Okay, you have to study like this. Just by heart this table. Okay, when you are asked to write down the equations, you should know. Okay, how the things are happening, like that study. If you by heart, sometimes you will be confused in the examination hall, so it will go wrong. So don't study by heart, just think at that time what is going, what is which charge, so who will be coming, so what is happening, like that thing. Okay, so at anode, both cases, who is releasing, which gas is producing? Chlorine gas. In the case of molten sodium chloride, cathode, sodium metal. Okay, sodium metal will be forming, and here hydrogen gas will be releasing. Okay, and if you are asked to write down the reaction, you should readily write down the reaction. Here chlorine gas is forming, right? So anode, so oxidation, Cl minus will release release 1 electron and become Cl. Okay, to make it balanced, make like this. Okay, then what is the reaction at cathode? Yes, sodium ions will gain 2 electron of this 2 electron and become sodium metal. Same reaction, okay, same reaction at anode in the case of aqueous sodium chloride, and at cathode, just think that water is the real man, real hero in this case. Okay, he's the Superman, right? Because he has taken over the Na plus and H3O plus ions, right? And it gained 2 electrons. Okay, gained 2 electrons and release this hydrogen gas. That is the reaction taking place at cathode. So this box you just study very well for the exam. Sure, questions will be asked. 1 mark question will be asked sometimes 2 marks, sometimes even 4 mark questions will be asked from this topic. Okay, now question paper you can see without these questions. Okay, 1 mark question will be like this: what will be produced at anode in the case of molten sodium chloride? So anode, just think anode, chlorine. Anode, both cases are chlorine. Okay, and sometimes you'll be asked twisted question like in aqueous sodium chloride, chlorine gas will be forming at anode. So in molten sodium chloride, what will be forming at anode? Same thing, but we will think that, oh, if it is anode, like that, don't think like that. Okay, same thing is forming at anode, but in the case of molten sodium chloride, sodium metal is forming. In the case of aqueous sodium chloride, hydrogen gas. Okay, that's it. That is all about this electrolysis of molten sodium chloride and aqueous sodium chloride. Okay, so hope you have enjoyed the video. Please watch the full video for the better understanding. Okay, and if you have any doubts, you can ask. Okay, you can comment. And please, if you like the video, please share and subscribe our channel. Okay, let us see on the next video. Till then, bye. Thank you. Have a great time.